Hello students, welcome to the 11th episode in our example problem series for Circuits 1 here at NDSU. In this episode we are going to cover using open circuit voltage and short circuit current to solve for Thevenin and Norton equivalents for the circuit that we see in front of us. It looks like we have a 15 volt source in series with a 1 k ohm resistor in parallel with a 6 milliamp current source in series with an 800 ohm resistor, all of that in parallel with a 1 k ohm resistor. Let's note terminals A and B. These are the terminals in which we are taking the Thevenin and Norton equivalent with respect to. Alright, our first step is going to be solving for the open circuit voltage, or we can just call it VAB. It's the voltage across terminals A and B. By inspection, VAB or VOC is going to be equivalent to the voltage across this 1K resistor as well as the voltage across the 6 milliamp source and 800 ohm resistor. So let's just label that as a node right up here. VAB. It looks like KCL is going to be a pretty good option to solve for this voltage, so let's get to it. We're going to sum these currents out. Let's label that, that, and that. And let's write the equations for those. We're going to have VAB minus 15 volts over 1K plus that's 6 milliamp plus VAB over 1K equal to 0. Let's skip a few steps and solve just for VAB. It's going to give us 4.5 volts for VAB. Okay, second step, we are going to act as though there's an imaginary line shorting terminals A and B. And we're going to call that ISC, or current over that those shorted terminals A and B, short circuit current. And we are going to do, I think we can do another KCL to solve for that, but we're going to change a few things. Since we're shorting terminals A and B, there's going to be no current through this 1 k ohm resistor, as well as the voltage across a short is 0. So in this case, VAB is actually 0 as well. Alright, let's do another KCL with that in mind. We will have, let's just put it up here, VAB, which is 0, minus 15 over 1K, plus that same 6 milliamps, plus whatever I short circuit is, equal to 0. Skip a few steps and simplify. ISC is equal to 9 milliamps. All right. Using those values, we can solve for the Thevenin resistance, which is just equal to VOC, or VAB in this case, over ISC. All right, 4.5 volts over 9 milliamps is going to be equal to 500 ohms. Okay, we solved for our Thevenin using open circuit voltage as well as short circuit current, but there's another way that we could do it by deactivating the dependent sources in our circuit right here and right here, and then taking the equivalent resistance of the circuit with respect to terminals A and B, we can also solve for our Thevenin. Let's do that. In order to disable a voltage source, we need to short it out. So, let's draw our resistor. That's terrible. short, this is where our voltage source would have been. This is the 1K ohm resistor. In order to deactivate a current source, we're going to open it. This is where our current source would have been. We have our resistor here. But this is opened. I know it looks terrible, but it's opened. It's our 800. Our last component, another 1K. Let's not forget our terminals A and B. Luckily, that made this one pretty easy. With this branch open, there's no current flow, so that just leaves us with a 1K resistor in parallel with a 1K resistor, 500 ohms. Awesome. Our R Thevenins match. Thanks for watching.